Hi guys, in this video we're going to talk about theoretical versus experimental probability, and then we'll work on some compound probability. So let's start with theoretical probability. So remember, probability is the likelihood of an event occurring, and theoretical probability is based on mathematical reasoning, and the following formula can be used to find the probability P that an event will occur. So if we have a number of favorable outcomes, then we can divide that by the total possible outcomes and determine the probability of that event happening. Let's look at an example. On our spinner here, they're asking us which shape does the spinner have the least probability of landing, and on which shape does the spinner have the greatest probability of landing. So we're trying to find the probability of each shape, which means we're going to take however many shapes there are, the number of that shape, over the total. So first we need the total. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 shapes. So all of our probabilities are going to be over 12. Over 12. So let's find each one. The triangle first. There are 3 triangles that I see. And when we reduce that, I get 1/4. There were also 1, 2, 3, 4 circles out of 12, so I get 1/3. There are only 2 squares, so I get 2/12. And there are 3 stars, so I get 3/12 is 1/4. So now you have all these fractions, and maybe you're wondering, well, how do I know which one is the most likely or has the least probability of it landing on, and which one has the greatest probability of it landing on? And we maybe need to convert those fractions to decimals. Convert those fractions to decimals. So 1 divided by 4, we get 0.25. 1 divided by 3, we get 0.33, and 1 divided by 6, I get 0.16 forever. 1/6 forever. So our least likely is the square. So the one that has the least probability is the square, and the one that has the greatest probability is the circle, which makes sense. There are the number of squares are far less than the number of circles. So it is less likely to land on the square than the circle. And we've already found the probability of each shape up here. So let's look at another one, experimental probability. This is the other one. So experimental probability is going to be based on actual experiments. Theoretical is because we maybe don't know the answer, or they're just theorizing this is the probability of this happening. Experimental means we're going to actually complete an experiment to find that prediction, find that probability. It's also called the relative frequency. And the formula can be used to find the following experimental probability of an event. We take the number of times the event occurred divided by the number of trials. So this time we would run a specific number of trials. So let's look at that. David tossed a coin 15 times and he recorded those outcomes. So the number of times tails was tossed is 6. And the number of trials performed is 15. So we would then put that into our formula. We want to find the experimental probability of getting tails. So I would say probability of tails. And I remember that is the number that happened out of the number of trials. And again, this can be reduced. They're both divisible by 3. So 2 out of 5. So that means every 5 tosses, 2 of them are probably going to be tails. We found that experimental probability. Out of 5 tosses, 2 of them will probably land on tails. Now, experiments can be performed to test that theoretical. We could have flipped a bunch of coins and said, oh, it's a 50-50 shot. But then the more experiments we run, the more specific experimental probability we're going to get. So in that previous example, we had a tossing tails as 2/5, but if we performed a bunch more, we would get closer and closer to that 50%. So if you know the theoretical probability of an event and the number of trials that are going to take place, you can predict the number of times the event is going to occur. We're going to make a prediction with that. So on this one, about how many times would you expect the spinner to land on an odd number in 120 spins? So this is our number of trials, and this is what we're looking for happen. So the probability of landing on an odd number. Let's find that first. That odd number is 1, 3, 1, 3. So just based on the spinner, I would say there are 4 out of 6 possible outcomes. So 2 out of 3 chances that happens. 2 out of 3 chances that happen. Now we need to multiply the probability of 2 over 3. We're going to multiply that probability times the number of trials. So 2/3 times 120, which comes out to be, this would be 40, so 80. So right here we get the spinner would have a chance of 80 times out of 120 landing on that odd number. Our last thing today we're going to look at is compound probability. So a compound event is a combination of 2 or more events, compound. Compound events can be dependent on each other, or they can be independent. Independent events are 2 events in which the occurrence of the first event does not affect the probability of the occurrence of the second event, whereas dependent events are affected by the first event on the outcome of the second event. So to find the probability of 2 independent events, we're just going to multiply their probabilities together. So let's look at an example of that. Adriana is tossing a number cube with faces numbered 1 through 6 and spinning the spinner shown below. What is the probability of tossing a number greater than 2 on the cube and spinning red on the spinner? So these events are independent because the outcome of the cube will not affect what happens on the spinner. It's not going to mean we have to get a 2 for the spinner to spin. They're completely separate from each other. So let's find the independent probability of each, and then we'll multiply those 2 probabilities together. So the probability of the cube, we're wanting to find what's the probability of all the numbers greater than 2. Remember, 6 faces, and the outcomes that are greater than 2, not equal to, are 1, 3, 4, 5, and 6. So there are 4 out of 6, which simplifies to 2 over 3 for the cube. And the spinner, there are 3 red selections out of 4 possible. 3 out of 4 possible, which does not simplify. So now we just take these 2 numbers, 2 fractions, and we multiply them together. 2 over 3 times 3 over 4, and we get 6 over 12, which simplifies to 1/2. So the probability of the cube landing on a number greater than 2 and the spinner landing on red is 1/2. 1/2. Now let's look at a dependent one. So on this one, Carlos has 3 comedies, 2 dramas, 2 concerts, and 1 horror movie in a DVD booklet. He will pick 2 DVDs from the booklet to play. What is the probability of Carlos picking a comedy and then a drama? So on this one, we should see they're dependent because the second event depends on the outcome of the first. But we still need to find that probability first. So the probability of picking a comedy, well, there's 3 comedies. 3 comedies, and he had 3 plus 2 plus 2 plus 1. So 3 out of 8 different options. 3 out of 8 different options. But now he has picked the comedy out, which means there's 1 less DVD there to pick from when he chooses that second option, that drama DVD. So there were 2 dramas, but now we have 1 less DVD to pick from. So there's only a 2 out of 7 chance he's going to draw that drama. That probability of drawing a drama has 2 out of 7 chances happening. But we'll still go ahead and multiply these two fractions together. So 3 over 8 times 2 over 7 gives us 6 over 56. And those are both even numbers, so we can cut them in half. But that is our most simplified fraction. So the probability of picking a comedy DVD and then a drama DVD is 3 out of 28. So we've looked at some theoretical, we've looked at some experimental and compound probabilities. I hope this helps and gives you some examples to refer back to, and we will try these out in class.